So without further ado, I want to introduce our speaker this evening, Loic Juillard, who is VP of Engineering at Summersource and has over 20 years of industry experience in the cloud services and AI industry. Loic has worked at Fortune 500 companies and has led the development of large-scale AI, data analytics, and cloud solutions during his career. So without further ado, Loic, if you'd like to share your screen.
Thank you. Thank you for the introduction. Yes, I'm going to share my screen. There you go. You should be able to see it.
Brilliant. Yeah.
Very good. All right. Thank you for the introduction. Hi, everybody. Thank you very much for joining this call today. And yeah, I wanted to talk about annotation. It's a critical area. If any of you have worked on projects, machine learning related projects, annotation and basically creating training data is a critical part of the success of our projects. And at Summersource, we're specialists in delivering a trusted platform and trusted annotated data to our customers and for their needs, machine learning and others. So today what I want to do is really talk about how you can be set up for success for processing that data, what you can do on your end to try to condition your project for success. And I also want to talk in the second phase and second part on what we're doing on our end to facilitate that work. So first of all, just going through some of the interesting stats. Just out there, about 2 out of 10 AI projects succeed. That's it. It's a very low ratio if you were to compare that with a more traditional development methodology like software development and others. And that ratio being low is really due to what we'll talk about today. So if you're feeling bad about having an issue with your project, then you should still feel pretty good about it because you're still on the top 25% in your class. So now, really, the main hurdles to developing these projects and developing solutions for machine learning is really two sides of it, two main sides of it. First of all, the customer, of course, it creates lots of data. You'll hear that. And this is the number one complaint. Number one thing we hear in the industry is we don't have enough data. Sometimes we don't have enough media to annotate, and sometimes they are not annotated. So these are sort of the two sides of the coin. So the other one is the discovery. Discovery continues throughout the project, causing training and rework. As you train your model, you realize certain things about the model and you want to retrain it. So there's actually a lot of rework. It's not a straight line. And then there's, of course, a topic very much covered in a lot of media is the bias and data diversity. This is a very difficult problem to solve. We've seen it in many industries. It's a frequent topic of conversation, and this is something that customers often struggle with. On the annotation side, so that would be either internally, if you annotate your data internally, or working with a provider, if you use a provider. There's really three main things. That aspect of quality is very important. The quality covers a large domain of issues. It's not just the precision of the annotation, but it's also basically meeting requirements, whether the annotation meet the functional requirements that a customer provides. And we'll go through this a little bit later. The quality is absolutely critical, and it determines very much the complexity and the time it takes to annotate the data, and therefore the cost, of course. Training agents, anybody, whether it's internal or external, can take weeks, depending on the complexity of your training material, training data. And we'll cover that as well. There are ways to mitigate this, so we'll talk about this. And the instructions, one of the most critical part of the project. Actually, we will very much put a lot of emphasis on this because the instructions very much condition is a big function of success for your project. And the agent may reprocess the data several times to try to meet the instructions, either because the instructions change or because they're too complex to be processed in one round. So what I wanted to do here is cover the path to production. And what you're seeing here, are the three steps, main steps of bringing a model to production. The very first phase is the one that is the most known by data scientists and AI group. They build a prototype. It often starts internally, and the general pattern is it's a group of individuals. It can be anywhere between 5, 10, 15 data scientists who got access to seed data, and they're starting to annotate these internally and process them to verify. Really, the goal for this is to determine the viability of machine learning technologies to actually solve the problem they're trying to solve. So during this phase, it's very much a work of exploration and rapid iteration within the company. Once the team has determined that there is, in fact, a viable solution there, that technology can address these needs, they transition to what I call the production model. So they are trying to actually inject more data. They're trying to get the model to be fine-tuned to produce a better outcome. And this is where there's really two ways of handling this. Either they're continuing to do the annotation internally, or they reach out to an annotation company, a third party, to annotate the data for them. And it is in that transition that most of the issues happen. Actually, the data show that about half of all projects fail at this phase. This is a main failure point for project development, because it seems that the companies never managed to really scale the annotation work. And we'll be talking about this in the next slide. So while these additional data being annotated, you also start receiving field data from a prototype that you may have developed and deployed to production. And that's compounding the problem, because now you have a need to annotate data, complemented with a new inflow of data that comes from the field that may have their own set of issues, and that also has to be addressed. The bulk of the work is really there. This is where most of the costs come from, is bringing a model to production. If you pass that hurdle, there is the next difficult part is the really having these models in operation. So now the model is deployed into production, actually servicing the needs, and you're continuing receiving data. That model needs to be maintained. It's not a one-time development. It doesn't go to production and remains efficient. It will have to be maintained. That's another aspect. Though this part is generally well understood once the production model phase is reached. Next slide. So we talked a little bit about the instructions. We talked about that transition from being a prototype to go in operation. Really, the instruction is the key function. Whatever you've experienced internally in the first phase of that development is really amplified once you get into a production at scale of annotating the data. And often what we're seeing is the annotations at first, when a customer comes in, are seen as sort of a linear thing. The belief is that they'll work internally, they'll write specifications and annotation instructions, and they'll hand that off to an annotation group that will produce the data based on these annotations. Where in fact, annotations are should be looked at more like a software development pattern. So you have branches, and the annotation instructions flex and flow based on the type of data and the observations that are made on the field. They are constantly evolving. And the same issues that you would have for software development manifest themselves also on the annotation instructions. How do you manage changes? How do you propagate these changes, and how do you figure out which data were tagged under what particular annotation instructions? So really, there's really four categories of changes we're seeing on the instructions. You have a main production line of annotation, which is basically where the bulk of data are going to be processed. And then you have an iteration loop where these observations are being made from the annotation or retraining of the model that prompt the customer to change the annotation and adjust them based on the number of criteria. And then there is the iterations that actually lead to a regression, where actually the change in annotation instructions degraded the quality of the model. So that's actually being pulled back. And then there is use cases centric instructions that you're seeing. They have special branches that will never be merged back to the main production, but continue being used for specific cases. Like, let's say for an automotive, the self-driving industry, for example, they would handle special cases of special types of road, or special countries, or type of signs that are not seen often, or behavior they identified in production on the road they would like to address are very specific to that condition. These are the 4 types of changes that we're seeing. Managing the change efficiently in a way that your annotators are kept in the loop, and that your data model and your data annotation continue being tagged and closely looped with these changes is very important to success. This is often where a lot of confusion happens. And talking about the quality earlier, this is often what we're seeing in terms of quality is that there's a disconnect and things can get messy. So another part of the complexity, and that's something that we've seen, and as machine learning models are becoming more and more complex, it's becoming much more prevalent issues than it was a year or 2 years ago. There is a function of time and complexity in your annotation, and that complexity comes with really 2 things: the type of media you're annotating, and the number of classes you're trying to annotate in one round. So 2D image with vectors, so vector can be bounding boxes and polygon, are the fastest, and raster, which is more pixel level annotation, is definitely more complex, and the video and 3D with vector and raster as well would be the most complex, and there's definitely an exponential curve there. Now by class, and that one is the most important one, there is a 2 approach there. Some would prefer having operates under the belief that it's better to just send it all the classes at once and have the agent annotate all of them, and others doing that incrementally. They inject a number of classes every time they reprocess the data. The best approach is definitely to take less classes. It takes time for the agent to memorize them. We've seen a range from 1 to almost 1,600 classes in one round of annotation. If you combine that with a video, it makes that really complex. To give you sort of an idea on processing task and processing media, the range goes from processing to process an image on vector annotations and bounding boxes. It's less than a minute. I believe it's 45 seconds, the lowest we've seen. The most we've seen was video on raster, and that can take a month and a half per video sequence. So definitely the month and a half is now the best way to go. Staying in small, short iterations and just injecting classes and annotating, processing the data over and over again on the small classes is a much more efficient way of getting to a positive outcome. I've seen a question coming there on the Q&A, and but I'm unable to. Yeah, I haven't seen it yet. Was there a question?
Bear with me. Let me allow Saeed to talk. Saeed, are you there? Hello? No, maybe not.
Okay, I'll continue. If Saeed wants to, he's back, then I'm happy to get his question. So now I want to sort of zoom in a little bit on the work of annotating. Let's assume that you've worked through these hurdles, and we're now at the time where actually the agent process the data. One thing that we're seeing is actually the agent operates in phases. And if you look at the different phases that an annotator goes through to annotate the data, there's really 4 main categories. And as part of our platform at SummerSource, we measure these things very closely because we want to understand how we can improve the efficiency of annotation and also give a customer a better outcome. So what we're seeing is really the agents first load the content, and there's about 20% of their time is spent on observing. So they're trying to make sense of the scene they're looking at and start thinking about how they're going to annotate the content. Then comes the preparation. So they're basically pulling out the classes they're supposed to annotate, and they're getting ready to actually start annotating, extracting the feature from that content. Then they spent about 40% of their time drawing. Drawing would be just doing bounding boxes or polygon or raster. If you're doing a raster for semantic segmentation, they're already annotating the content. And they spent about the same amount of time adjusting or reviewing. Once they believe they're done, they start going into the fine details and move things around a little bit. And this is really important to understand. When you increase the quality, that drawing percentage goes down, but the quality requirements, that is, the adjustment and review increase exponentially. On a more complex project that have very fine quality requirements, either really in two ways. Either there is a relational constraint between classes. For example, you always have a person on the bicycle, and the agent has to really make sure that this is the case, that all these constraints are respected, or that you have a very high demand in terms of quality. We, for example, have customers that ask for perfection on the annotation. So it's a 1 pixel deviation from the edge of an object, let's say a car or a person. Then the agent will literally have to zoom into the edge and absolutely look at every pixel one at a time. So of course, this is a very costly operation. And that time spent by the agent will increase exponentially. So of course, we're working on automation, we're working on software to actually accelerate this. We'll talk about this in the second phase, but it is something to remember. So quality is good, but it comes at a cost. If your model does not require high quality, I would stay within an acceptable framework that really is applicable for you. And that would be something that can be part of the experiments you're running early on, is try to figure out with different types of quality what works best for the outcome you're hoping to get. So the rework. So rework is an important part of the annotation. It happens for good and for bad reasons. So I'll start with just giving an idea of how that works. The rework is 90% of the rework is traced back to annotation gaps. And actually less than 2% of the rework is due to annotator misses. And about 2/3 of rework could have been determined with only a fraction of the data annotated. The way these things come about is often the agents are processing data and annotating content really efficiently, but there was a change in instructions, and these don't propagate really well with the agents, or they are misrepresented to the agent. The agent misunderstands the changes, operates under the fact that they've understood the changes, deliver an entire batch of data to the customer, only to realize that it wasn't what they were expecting, and there has to be a refinement of the instructions and retraining of the agent for them to deliver. So this again goes back to that notion of instructions. Making changes to the annotation instruction is very complex. It's complex for the agents to adjust, and it's also complex for the customer to express that in a way that is well understood. So the first thing in sort of secret in creating, there's a few things in creating instructions that for roles that I would follow to be successful. First of all, is have the clear definition of the problem you are solving. We do see a number of projects, for example, that start with annotating a certain number of classes, but it often starts drifting into all kinds of direction. And this is where there is a scope creep in terms of classes being annotated, a complexity around relationship between classes, and and this is where a lot of quality issues happen. So isolate a self-contained subclass if possible. And the annotation instructions work best when the problem is specific to avoid the sprawling, right? So solve one problem at a time. It's less costly to reprocess the data for different use cases than trying to tackle all use cases in one round. The building of the annotation instruction is not as much as a handoff as it is a collaboration. We really are developing a product here that is handling more of an iterative approach. So there's a constant feedback loop with the customer in a way that we don't process a large batch of data to realize that actually annotation were not accurate, both from a customer complexity standpoint and us on the delivery side. Leverage the team know-how. We have agents that have done this for 3, 4, 5 years. They've processed 10, 15, 20,000 each images and videos with probably the industry you're working in, and they're able to advise on how to best handle this. And again, I can't stress that enough. The iteration, process iteratively, very small steps, rapid changes is best for everybody. Now, the items, this is a really good list that we're actually using internally to make sure we capture everything. The items are often missed in annotation instructions. They don't come about during the prototyping phase, so that first phase you saw earlier. They often come later on, once the richness of field data comes into play. They realize, oh, there's all these other things that now we need to handle. So, for example, when should adjacent objects of the same class be included in a single annotation versus separate annotation? Right? Do you want a group of cars to be grouped together, or do you want each car to be annotated separately? Should we include only visible portion or extrapolate it to imagine the full size? That's really important when we have an occlusion. Do you want the agent to imagine what the rest of the object is, or do you want just to annotate what's visible? Should an annotation go behind the occlusion or use 2 different annotations? Should we include extremities? That's a frequent one, very frequent. So for example, do you want the antenna that sticks out of the car, or you don't want the antenna? Do you want the mirrors or not? The same with a person. If they're holding a purse, then you want the purse with a person or not? And these often are a main cause of rework. Any nuance around when we should ignore versus annotate an object. A typical example of this is when is the object too small to be annotated? If you have a car in distance that is only a few pixels big, are you really interested in a 20 pixel object, or can we just not do that? Where are they located? One example we had recently is if you have a cone on the road, well, obviously you have to annotate the cone. But if that cone is actually sitting on the curb, because they remove them and just stack them up, right? What do? Should it be annotated? Are you interested to see this or not? Same concern with people, right? If they're waiting at the bus stop next to the road, you'll probably want to know that because it is an obstacle. It is something you need to be aware. But let's say now there's a divider in that road. You have a train track or subway track, and then you have a station on the other side, and there's people waiting there. Are they considered pedestrians? Are they something you want us to annotate? And that has to be specific. These are things I'll learn as we receive field data. On the physical object or reflections, that's a tricky one. If you have the reflection of a person in the mirror as they walk in, let's say, a street or a hallway, do you want us to annotate the reflection as well or not? Or do you want a different class to signify that this is a reflection or not? So these points are really important. They come about very often, and these come in often later on as a cause of rework, as things that were not really known, and the agents sort of interpreted in their own way because they did not have clear instructions for these things. So efficiently does and agility go hand in hand in this. The faster, less costly way to working a model is sending short tasks, be agile, and iterate. This is really important. It's not a handoff as you would do in civil engineering where you're building a bridge. It's not how it works. It's just later iterations, and the data you're receiving will educate both your annotated data provider and yourself on exactly what adjustment is to be made and how to handle that. Process the data in layers rather than large round, what we talked about earlier, and then process in batch and less often. And and test often, so that you actually bring in a small amount of data in batch and test your model against it to create that validation loop rapidly. Sometimes we see customers that wait a month worth of data to retrain their model, and then they realize there's actually a regression. The model is not performing as well. And that's a painful change because it's a month of data that might be lost and that might need to be rectified. So now I want to talk about what we're doing on our end, besides sort of helping and guiding the customers in building these annotation instructions, is what we're doing to accelerate all this. Even if you've been successful in creating your instructions and collaborating with your company providing instruction, the annotation to you, it's still tedious work. Annotating data, I mentioned it can go from a few seconds to a month and a half. We are seeing more and more complex use cases, and the agents are spending an extremely amount of time annotating the content for each pictures of video they're receiving. So what are we doing? So we started working and innovating on creating machine learning assisted annotation. It's really to create a system that is able to help assist annotators to annotate the data rapidly. And that's a technology that's developed specifically for annotation. It doesn't solve the same problem as what our customers are trying to solve, like for self-driving cars and other things. But it is very specific to the annotation with quality in mind. And that's the main difference. So we annotate for quality. We annotate with great precision. And we have the help of an agent to sort of guide the system to look at the right thing. So first of all, often we get that question is, could we develop a model good enough that we could do pre-annotation? Well, not really. To this day, the precision of an annotation, when you talk about having an annotation is accurate to, let's say, 2, 3, or 4 pixels of the actual edge of an object. Pre-annotation to an unguided annotation, it doesn't get us to that level of quality, not even close. And actually, what we've noticed through testing is the initial data provided by human is the most valuable information in the annotation process. If you go back to that circle that I show with sort of the drawing time, that drawing time, 90% of that 40% drawing time is spent actually outlining the object. But of course, the agent very rapidly knows what they're looking at, where the edge is. In their mind, they already have that done. It's actually the effort of drawing the shape that it takes the longest. So we're focusing very much on that. And with a human clue, the machine performs detection quite well. Once you've told the machine where to look, they can actually get to that high level of quality. The other really important thing is the manual adjustments are roughly equal to redrawing. So we do need to get to a model that is really relatively accurate. If the agent for any reason doesn't feel that it's actually close to what the customer may expect, they actually tend to redraw the entire thing rather than rectifying the shape. Just for time, it just goes faster for them. So what we've done is we call that a few click annotation system. We're using synthetic data in this particular case, but we also use real data for some of the objects that we're detecting. Created the same unit. We have our internal base model to detect certain classes of objects, and using Dexter as a detection technology. So we derive a heat map from simulated extreme clicks. We basically ask the agent to indicate which 4 extreme points on an object is. Then we concatenate the heat map to the image. And then we pass the input to a segmentation model to get a prediction of the raster mask. then we take that raster and we apply the raster to polygon if we want to have a polygon, or we leave it in a raster if we want a raster annotation. This is used in production, and results were absolutely incredible, are incredible. So just to give you an idea of what we're getting in terms of quality, that's our number one priority for what we do is the quality. The speed comes second. So this is on the top, this is what we got through a manual, and on the bottom, this is what we got for a few clicks. And you wouldn't find the difference. There's actually none. And if you run an IOU on this, if you actually run a comparison based on ground truth, you would find that actually the few click came out to be more precise than the manual annotation. So in terms of annotation time, this is sort of the improvements that we've seen. And you find a similar drawing that we had earlier for the time. Let's say about 1 minute, 30 seconds for a particular shape. Just drawing a polygon around, let's say, a car or a road. And just using a few click annotation, what we've seen is the ratios are roughly the same, but that time dropped about half, maybe even more in some instances, for an equal or better IOU level. So incredible success that allows us to process basically twice the amount of data within the same amount of time, which reduces costs, of course, and improves the visibility of these projects and the likelihood of a project to be successful. So sort of that's my last slide, summary slide there for well, how can I increase my chance of success? We've seen only 2 out of 10 of these projects are successful. How can we improve this? Obviously, we need to get better at this, and it's all about efficiency. Getting a machine learning model in production is costly. It involves a lot of data. There's a lot of logistics around collecting the data, annotating, and training model. So if I would summarize this in 4 main points, there is the instructions, and I can't stress enough the importance of having a right process in place. They have to be complete, and we have to have the life cycle in place. Use rapid iterations. Big batch don't work. It's very costly. Small revisions and just-in-time annotation. It's something that we work with the customers a lot. System integration. So we talked about a feedback loop. Automate as much as you can with your providers, whoever gives you the annotation. It's a really important thing. We have APIs on our side you can integrate with. You can absorb the content that was annotated, retrain your model automatically, provide that feedback automatically. It allows that to run more frequently, to not have people in the loop, and get to greater accuracy faster. And last but not least, automation is required. Your provider should have a fair amount of automation. At this point, this is how we can annotate data at scale. There's no way to do this entirely manually for every single classes and problem that we're trying to solve within the ML world. And this was my last slide, so thank you. I saw a few questions coming in, so.
Sure, brilliant, thanks for that. No, say we've had a few questions come in, and obviously we've got the pre-submitted ones as well. Just to those watching, make sure if you've got any questions to get them in the Q&A button below. One of the brilliant pre-submitted questions someone had asked was just asking you if you could possibly go into a little bit more detail on the ground truth in machine learning.
I mean, in what sense? So ground truth in machine learning it's how basically we set the basis for all our analysis, right? So establishing a ground truth is really required. It's used in many ways. As we're using training data, we found, for example, using gold task against a ground truth is really helpful. Gold task is a way to QA basically the work done by annotators by monitoring the annotation based on a set of known tasks that were already annotated. So we use that quite often. It's a good function. It's not the only function that measures quality. Too much emphasis I think is put on the beginning on having ground truth data and using gold tasks for that. It's a multiple prong on that approach, but it's a good way to baseline the quality. You also, as your data change, your ground truth data have to evolve with it, and that can be a problem, especially as you observe a bias in production. How do you adjust that? It's a very complex issue to solve.
Okay, so another's asked, can you explain how batch annotation can be moderated by humans?
How batch annotation can be moderated by humans.
Sure.
Well, the first thing is it's actually how to avoid moderating it with human. We have all the tools and systems in place to actually measure the efficiency of model. It is actually, in my opinion, a much better investment than trying to automate that process as much as you can by interacting with your APIs and kind of pull the data, train your model, and measure the output. It's true that initially, early on in the stage of a project, that automation might not be in place, and you still need to have human in loops to try to adjust and figure out exactly how to best approach the problem you're trying to solve. So the best way is to rely on metrics and data to establish metrics for success early on. Establish exactly how you're going to measure quality. Common ones on the map and IOUs, these are widely used, but that actually might not be the best thing for the use case you're trying to solve. So spend time trying to think of ways to best measure success and use that, and then automate that as soon as you can.
Another asked, with the improvements in machine learning and computational power, how do you see the annotation process evolving over the next couple of years?
That's actually a very good question. This is definitely a huge area of investment for us. We are seeing some radical changes in the way we are approaching this. The technology that we're developing here is really intended to be multimodal, to really address a lot of cases. We're currently very focused on specific classes, specific areas of focus that we're trying to solve. We're saying with the increase of processing power that we'll be able to create systems that can react and respond to any type of annotation. That can be agricultural use cases or self-driving cars, or that can also be satellite imaging. We'll provide the model with the base ground for success, and we'll have a system by which it can respond and start annotating data and train itself to be better and better at doing the task that it's doing. So be less static on what it's trying to solve, or dynamic in responding to these changes in requirements and even use cases. The world of annotation is incredibly broad, and we're just barely now scratching this.
So Mark's asked, he said, great presentation. It sounds like automated image annotation works well as a structured learning paradigm, i.e. with human annotation leading the way, but few click clues might be good enough. Are there best practices regarding the few click approach, and are some of these types of features or edges especially high priority?
Yeah, there are. We're actually researching, we're actually leading a number of research there, especially around the effective quality and what are the best methods of input for the agents to sort of bring up the quality or get to the quality that is required. There is, because we're so focused on quality, agents tend to overshoot the quality, where a customer asking for, let's say, a 90% accuracy is going to get 99% accuracy because the agent just is used to produce that level of quality. We actually are looking for ways for agents to, first of all, realize that the quality is within specs, and two, can they provide actually less of these points or a different type of annotation to get to these models faster. So I'll give you an example of different classes. We've seen cars here. The cars is a defined object. It has a shape, and it's mostly the same shape. I mean, cars are different, but they kind of all look alike. Now, if you compare this with annotating a sky or a cloud, now that notion of shape has disappeared. It's more about the contrast, or it's more about this, the environment, the context that the annotation is done in. how do you approach these things? And these 4 clicks are really the best way of doing this. So we actually look at a different input. We've run these tests for vehicles, and we've determined like 4 points was actually the most efficient way. Now we're trying to see, does that change? Does that evolve? There's also a set of class that is an abstract set. Not abstract, we call that background objects. So like a road, and a customer asks you to annotate the road, but ignore the objects on it. Just imagine what the road would be like if none of the cars were on it. It's extremely difficult for a machine learning algorithm, right? You have to tell him what to ignore and what not to ignore. And that training is complex. And providing these different points is definitely going to be strategic and very important in getting to the quality we want.
Absolutely. Another's asked, are there any standards currently being established in the industry for annotations?
Are there standards? I think we're talking about this more and more over the last few months, a few quarters. There's recurring themes there, and these are being defined as we're speaking. There's definitely an interest in the field. There's been a lot of effort put into academia research on machine learning. That's more of a sort of a practical aspect of machine learning, or called applied research. We're defining these as we're speaking. So yeah, I would say within the next year or so, you're going to start seeing sort of a criteria for success and criteria for successful annotation that pertain to certain industries, and that's going to be provided as guides to customers, so they get a better sense of where to put their effort and focus.
Nice. Another had asked, what do you see as the main challenges to obtaining a high quality data set?
The main challenges. Well, the one I sort of listed early on are really the critical one. That high quality is going to evolve. So at first, you have a sense of quality on the small data set you start with, and you realize there's a set of problems and you have to solve. As you're bringing in field data and you start really running your prototype in production, that notion of quality will evolve into something different. And the main thing that I really want to stress on is that notion of iteration. You will never be really done. It's going to be a constant rework of your previous assumptions with a new set of data, a new set of understanding of the problem you're trying to solve. Even when you get to the later part of your model, where it's now in production, it's operating, and you get into sort of a maintenance mode, it's still a learning experience. Your model will over time degrade, and you're going to have to constantly retrain it with new data, new shapes, whatever problem you're solving, so that you continue operating at the level that you expected. So it'd be iterative, and just always realize that it's not done. It's never really done. There's always an influx of data. There's always a path there.
Sure.
Greatness of getting better.
Irfan has asked some advice, actually. He said, what could be the max number of classes for which the machine/deep learning models will be able to produce good results? He says, I'm solving a problem in which there are more than 1 million distinct classes. I tried my best, but I couldn't get a reasonable accuracy.
Yeah, that's a good question. So that class count is actually important, somewhat important. It's more of the diversity of scenes. And there's a point where we have to switch to a multimodal approach to solving this. So when you reach to such a high class count, it's really about starting working on your ontology. Really have an ontology of classes and see if there's grouping that can be done, and focusing on a particular area of the model, and have again a multimodal approach to solving these. Something we're also looking at right now. It's a complex problem. There isn't a whole lot of solutions out there for really broad scope to ML solutions.
Sure. Larry has asked, he said, annotations are often used when the ground truth isn't available, but the task of annotation is subjective across many fields. How many people do you believe it takes to form a ground truth?
It really depends on the size of the model and the complexity of what you're trying to annotate. We've had a team of 4 do it, and we have a team of 600. It really depends. There's sometimes customer would prefer multiple submissions, sometimes they use goal tasks. So it really also depends on the methodology you want to use to get to that ground truth. I would say that there's probably a relation between the class and the complexity, but that's through experiments that you'll find out. So starting internally, get a sense, and then start partnering with it, and then you'll get a sense for really what it takes to get to that level.
Mm-hmm. Another has asked from a pre-submitted question, what's the best way to ensure labeling is consistently accurate across all of your data sets?
That's a very practical problem to solve. So the accuracy and consistency of your labeling is going to be only as good as the training that annotators receive, right? And so the more context you can provide on the problem you're trying to solve and the details about your annotation you can provide up front to the list of questions I had earlier and sort of a methodology, the best the agent would be, or the annotator would be ready to respond to what you're saying. We're seeing that when annotations are well made, or the annotation are well understood, so in projects we have little changes in the annotation guidelines. After 2 to 3 weeks, it's fairly consistent, and we actually rarely get an issue. Annotation don't change, that consistency is there. Generally, annotators stay on the same project for the duration of the project, so you're going to get to sort of a consistency, and actually less QA is required at that point. The issue is that consistency it is rare that you're seeing a project that does not have an annotation instruction change. Actually, we only have very few of them. If your project lasts for a month, you're going to change that, and every time you make a change, it has a ripple effect on your quality. There's a whole change management process that is established. So that consistency is only achieved by clarity of instructions and then training, making sure that agents understand that. That's being asked to do.
Brilliant. Another had asked, how to do online network-based data labeling?
Online network-based data labeling. So I'm assuming this relates to being able to submit content through like crowdsourcing, maybe, it's a whole different aspect. It's through crowdsourcing is really meant for cost optimization and not so much for quality. There's special use cases for crowdsourcing that work well in crowdsourcing. For what we do there at SummerSource, we often we mostly deal with high accuracy, high quality data sets with complex class structure. The attractiveness of the pricing may lure some customers to go there, and often enough they come back to us because they are not getting the quality that they actually need. So there's some use cases where it works well, though it appears that as we progress through in the industry and solve more and more complex problems, that quality is just becoming paramount, and customers tend to really ask for quality up front. This is where we're solving the issues.
Sure. And another has asked, one of the pre-submitted questions has asked quite a prevalent question, and asked, how has the data annotation process been impacted by COVID-19 with the current pandemic? Have you seen any sort of trends at all?
No, we haven't really had an impact on our side. We maintain highly secured facilities in our processing centers, and of course, with COVID, this is something we had to revisit because concentrations of people is undesirable and not allowed in some areas. So actually, we moved to a work from home solution, and we were able to bring the same level of security on our work from home solutions, so just digital security, encryption, and so forth. The same level of trust in a work from home environment that we did within our office. So we can operate both ways. We also have the benefit of operating in several countries. So some of them are in a different place in terms of COVID. So actually, some of our countries are they are not affected by COVID. So that has mitigated some of these issues.
And one I always like to ask in webinars, what are you personally looking forward to working on at Summersource over the next sort of year and a half?
Personally, we're making incredible research findings and innovation in the world of annotation. It's a greenfield area. There hasn't been a lot of focus there. We have an incredible data lake, data collection mechanism where we understand in great details what is happening during the work of automation. We're mining that data to understand areas of improvement. We have a team of researchers that constantly try, innovate, and bring up new solutions that are very specific to the annotation world. To get to a point, our ideal world would be that we can annotate anything, any use cases at very high speed and very high accuracy. And the technology, the field of research there is extremely interesting. We're well placed to deliver on this.
Sure. And probably got time for one more. Another had asked, do you personally see any new business models emerging as annotation technology and awareness is improving?
New business model. I do see a similar move towards cloud services, as we've seen for infrastructure years back, or even other areas of software development, where your provider is becoming is more utilitarian in the sense that you can invoke them through software and have a better structure to submit your data. There's less human involved and actually more automation and that ability to have the elastic growth as well, where you can ask for more resource and contract the resource as needed. This is definitely something that I see happening. At the scale we are looking at developing and delivering machine learning solutions, I think that's the more likely scenario.
Sure, absolutely. Well, that's covered the questions that we'd had submitted in. I know there was quite a few there, so thank you for answering them.